resistive elements. In this course, we study linear circuits. That is, these techniques are valid for low voltage circuits where Kirchhoff's laws are valid. All linear elements follow the superposition principle frankly, it's surprising that it happens in circuits. So if I think about analogies of what do I mean by superposition, there is superposition in Newton's second law. And what we mean by there's this thing called the net force. And the net force is the sum of a series of individual forces that act on an object. But this guy, this tells us that there's only one resultant force. Even though there are many forces acting on this, there's only one resultant force. And by the way, electric fields also follow superposition. Nature is not that way at the atomic level, but it is at the classical level. Now, to give you a sense of what this means in circuits, let me give you an example. In this example, what we're going to find here is that we're going to apply superposition to linear circuits. So let's think about multiple circuits. So let's say that I have some element that looks something like this. I have an element that comes along, and let's say that I have one element here, and let's say I have a source here. So in this case, let's color code these to make it a little bit easier. So now I'm going to say that I have some voltage source V1, and I have a collection of elements. So what we're going to focus on is that I have these yellow elements, but the one I'm most interested in is this blue one. So what do I know about this blue one? This blue one is going to have a current flow, which we're going to call I1. So what makes sense here is that we could then say that the voltage source V1 causes current I1. In other words, I1 and V1 are proportional to each other. Now what we're going to do here is that we're going to add a second source to the circuit. Okay, so imagine that I now have this situation where, let me move this over here a little bit further, and I'll probably have to adjust this. So what we're going to do now, you know what, I'm going to bring it down. We're going to add a second source into the circuit. So now what does this circuit look like? So if I bring this guy down here, what we're going to do here is that we're just going to randomly add a source anywhere we feel like it. So let's say that I have another element here that I've added. Again, this is just some arbitrary element. And now I have my second voltage source that's going to look something like this. So when I look at these sources here, let's say that we make this a purple source. This guy is going to be plus minus, and this will now be V2. So now if I focus on the current of this source, here's what we're going to find. That the net current, I, implies here that this current is going to be equal to not only the first current, but it's also going to be equal to the second current. And this is what we're saying is superposition here. So superposition implies that V1 plus V2 are then directly proportional to the current I1 plus the current I2. That there's a direct cause of these current, and it's very similar to Newton's second law. In other words, this is the resultant source, and this is the you know what? I cannot say what I just wrote. That these sources here cause a resultant current through that element. That's superposition right there. For in that case here. So now, here's what we know about resistive elements. Resistive elements are well studied in your Physics 4B class, are modeled by Ohm's law. And Ohm's law says that the resistance is equal to the voltage divided by the current, where it is assumed that R is equal to a constant. If it's not a constant, we can't apply Ohm's law. Ohm's law is clearly linear since mathematically voltage is proportional to current. Plotting this shows that if I plot current versus voltage, then I'm going to have a linear line where the slope in this case is going to be 1 over R. And if it's ohmic, that slope has to be a constant. That's why we know resistors have to be linear. Resistors are linear and passive. In other words, they do not transfer energy into the circuit. They dissipate it. So then our sign convention is that if I have a resistor and I have some voltage drop, then the current has to enter the positive terminal. If it follows the sign convention, where Ohm's law shows that V, the voltage across the resistor, is R times IR, and the power of the resistor, by definition, is the current times the resistance, but through Ohm's law, we can rewrite this to read either in terms of voltage or current.